September 26, 1914. 6:47 a.m. The chalk hills of Picardy, France. Lieutenant Wilhelm Schaefer of the 16th Bavarian Reserve Infantry Regiment watched through his binoculars as French infantry emerged from the morning mist, their dark blue coats and red trousers making them visible at 800 metres. Behind him, mounted on its heavy sledge mount, sat the weapon that would define the next 4 years of warfare, the Maschinengewehr 08. What happened in the next 90 seconds would be repeated tens of thousands of times across the Western Front, a mechanical harvest that would redefine the very concept of infantry warfare. Schaefer's two-man gun crew, Gefreiter Hans Brenner on the trigger and musketeer Otto Klein feeding the canvas belt, had their weapon trained on the approaching mass of men. The French were advancing in traditional formation, company columns at 50-metre intervals, exactly as their tactics manual prescribed. They had no idea they were walking into a killing zone that would leave 340 men dead or wounded in less time than it took to brew coffee. The MG08 opened fire at 650 metres. The sound, a distinctive hammering roar at 400 rounds per minute, carried across the valley like industrial machinery. Through the acrid smoke, Schaefer watched as the leading French company simply collapsed. Men didn't fall individually. They fell in groups, in rows, as if some invisible scythe had swept through their ranks. The survivors tried to press forward, officers waving swords, sergeants shouting encouragement. It made no difference. The MG08 fired 7.92mm rounds at 2,700 feet per second. Each bullet could penetrate 15mm of steel at 500 metres, more than enough to punch through a human body and continue into the man behind. The gun didn't aim at individuals. It didn't need to. Schaefer's crew swept the weapon back and forth across preset coordinates, the water-cooled barrel allowing sustained fire that would have melted air-cooled designs in seconds. In 90 seconds, the MG08 expended 600 rounds. 6 canvas belts of 100 rounds each fed through the weapon's action with mechanical precision. The French attack, which had begun with 420 men, ended with 80 reaching cover. The rest lay in rough lines marking where the machine gun's fire had swept across them. This was not combat. This was industrial slaughter. The MG08 machine gun, properly designated Maschinengewehr 08, was not the first machine gun. That distinction belongs to weapons like the Maxim gun or the Gatling. But it was the first machine gun to be fully integrated into infantry tactics, the first to be produced in sufficient numbers to dominate a battlefield, and ultimately the weapon that forced every army in the world to completely rethink how infantry combat worked. The story of the MG08 is the story of how technology made traditional warfare obsolete, how industrial capacity became military capacity, and how a single weapon system killed more men than any other small arm in history. By November 1918, the MG08 and its variants had fired an estimated 280 billion rounds in combat, billion with a B. To understand that number, imagine a line of bullets stretching from Earth to the Moon and back again, twice. That's roughly how much ammunition German machine guns consumed during the First World War. Each of those rounds was manufactured to tolerances measured in hundredths of a millimetre, designed to feed flawlessly through a weapon that could maintain fire for hours. The MG08's origin story began in 1901 when the German Army's Rifle Testing Commission evaluated Hiram Maxim's recoil-operated machine gun design. The German military had watched machine guns in action during colonial campaigns and the Boer War. They understood the potential. What they needed was a German version, manufactured to German standards, optimized for European warfare. The task fell to the Royal Arsenal at Spandau, later to Deutsche Waffen- und Munitionsfabriken DWM. Chief Engineer Friedrich von Martini studied Maxim's design and made crucial modifications. The British Maxim used a toggle lock mechanism and was relatively light at 27 kilograms. The German version would be heavier, more robust, and utterly reliable. German military doctrine demanded absolute certainty. A weapon that worked 99% of the time was unacceptable. The MG08 would work 99.99% of the time, or it wouldn't be adopted. The development process took 7 years. Every component was tested to destruction. The bolt mechanism was cycled 500,000 times. The water jacket was pressurized to 3 times operating pressure. The barrel was proof-fired with overcharged ammunition. When engineers found weaknesses, they redesigned. When they found potential weaknesses, they redesigned. The final MG08 specification approved in 1908 weighed 26.5 kilograms for the gun itself, plus 32 kilograms for the Schlitten 08, the sledge mount. Total weight with 1,000 rounds of ammunition, water for cooling, and tools exceeded 140 kilograms. This wasn't portable firepower. This was positional firepower. The German army planned to use machine guns as defensive weapons, positioned in fortified locations to control key terrain. Mobile warfare would be conducted by infantry with rifles. Machine guns would hold ground. This doctrine would prove prophetic in ways the German General Staff never imagined. The MG08's action was brutally simple and absolutely reliable. When fired, the barrel recoiled backward against a toggle lock. This toggle, a jointed arm mechanism, broke downward at the joint, extracting the spent cartridge. A spring returned the toggle to battery, stripping a fresh round from the canvas belt and chambering it. The entire cycle took 0.15 seconds, 400 rounds per minute, but unlike rifles, this rate could be sustained. The 7.92 Zug 57mm Mauser cartridge was perfectly suited to machine gun use. Developed in 1888 and refined through 1905, it fired a 154-grain Spitzer bullet at 2,700 feet per second. Muzzle. Energy exceeded 2,600 foot-pounds, enough to remain lethal beyond 2,000 meters. Crucially, the rimless cartridge design fed smoothly through automatic actions. The canvas belts, each holding 100 rounds, could be linked together indefinitely. The cooling system was the MG08's defining feature. A steel water jacket surrounded the barrel, holding 3.7 liters of water. During sustained fire, this water-absorbed barrel heat through direct contact. As the water heated toward boiling, a simple condensation system captured steam, condensed it back to water, and returned it to the jacket. In theory, an MG08 could fire indefinitely as long as ammunition and cooling water were available. In practice, barrels wore out after 10,000 to 15,000 rounds. Barrel changes required 90 seconds with a trained crew. The weapon sights were sophisticated for 1908. A rear aperture sight adjustable from 400 to 2,000 meters, and a front blade. More importantly, the MG08 used indirect fire principles. A gun commander could calculate firing data based on map coordinates, set the weapon's elevation and traverse stops, and engage targets beyond visual range. This transformed machine guns from direct fire weapons into area denial systems. You didn't need to see the enemy to kill them, you just needed to know where they would be. When war erupted in August 1914, the German army fielded approximately 4,900 MG08 machine guns, organized into company machine gun detachments. Each infantry company had 2 guns. This represented the highest machine gun density of any army in 1914. The British Expeditionary Force had 2 guns per battalion. The French army had been slower to adopt machine guns, preferring the offensive spirit of infantry charges. The Germans had studied the Russo-Japanese War of 1904 to 1905, where Japanese machine guns had slaughtered Russian infantry. They took notes. The opening campaigns of 1914 demonstrated machine gun effectiveness immediately. During the Battle of Mons on August 23, 1914, British infantry armed with Lee-Enfield rifles delivered such rapid, accurate fire that German troops reported facing machine guns. But when actual German machine guns opened fire during British withdrawals, the difference was unmistakable. Private Edward Thomas of the 2nd Battalion Royal Irish Regiment described his first encounter with MG08 fire. We were crossing a wheat field in extended line, maybe 150 yards between platoons. We heard this sound, like fabric tearing, but amplified 1,000 times. The man next to me, Billy Crawford, just fell. No dramatic spin, no cry out, just fell like someone cut his strings. Then the man behind him fell. Then 3 more. The sound continued, that terrible ripping sound, and men were falling everywhere. We hit the dirt, but the bullets found us anyway, clipping through the wheat stalks, striking the ground, striking men. In 30 seconds, our company lost 47 men. We never saw the gun, just heard it and died. The German advance through Belgium, and France in August and September 1914 relied on speed and manoeuvre. Machine guns provided security during halts and covering fire during withdrawals, but the campaign was too fluid for positional machine gun warfare. That changed in October 1914 when the War of Movement ended and the western front solidified into trench systems stretching from the English Channel to Switzerland. The MG08 had found its perfect battlefield. Trench warfare created the conditions where machine guns became absolute masters of the battlefield. The tactical problem was simple but unsolvable. Infantry had to cross open ground under observation to reach enemy trenches. Machine guns, positioned in hardened emplacements with interlocking fields of fire, could engage those infantry across their entire approach. The mathematics were brutal and inescapable. An MG08 could fire 400 rounds per minute. A well-trained crew could sustain 250 rounds per minute, accounting for barrel cooling and belt changes. Each bullet had a lethal radius of approximately 1 meter, against troops in the open, accounting for near misses causing wounds. At optimal range, 500 to 200 meters, a single machine gun could theoretically engage targets across a front of 50 to 100 meters. In 1 minute of sustained fire, that gun put 250 bullets into roughly 5,000 square meters of space. The probability of avoiding hits while crossing that zone approached zero. German defensive doctrine quickly evolved to maximize machine gun effectiveness. Primary positions were constructed in reinforced concrete pillboxes with walls 1 meter thick, proof against anything except direct hits from heavy artillery. Embrasures, firing ports, were narrow, perhaps 30 centimeters wide, presenting minimal targets while allowing broad fields of fire. The gun position itself sat below ground level, only the water jacket and barrel exposed. Machine guns were positioned in depth. Forward guns engaged targets at maximum range, breaking up attack formations. Secondary guns, positioned 50 to 100 meters behind the front line, caught troops who penetrated the first zone. Reserve guns covered approach routes and communication trenches. A typical German division sector, covering 3 to 4 kilometers of front, might contain 80 to 120 machine guns by 1916. This created defense in depth where every meter gained cost attacking infantry dearly. The Battle of the Somme, beginning July 1, 1916, demonstrated MG08 effectiveness at industrial scale. British planning had called for a week-long artillery bombardment to destroy German defences, followed by infantry advance to occupy the pulverised trenches. The artillery bombardment, involving over 1,700 guns firing 1.7 million shells, was the heaviest in history to that date. It accomplished almost nothing against German machine gun positions. Lieutenant Friedrich Wittig of the 180th Infantry Regiment, holding trenches near Beaumont Hamel, wrote in his diary about the bombardment, "For 7 days we lived, like rats in the deepest dugouts, 30 feet below ground. The earth shook continuously. Dust filled the air. We couldn't hear ourselves think over the explosions, but our dugouts held. When the bombardment ended, we knew what came next. We rushed up the stairs, dragged the machine guns from their shelters, mounted them in the firing positions. The whole evolution took perhaps 3 minutes. Then we waited." At 7:30 a.m. on July 1st, the British artillery lifted from German front lines to rear areas. In hundreds of dugouts along a 25-kilometre front, German machine gun crews emerged and prepared their weapons. Across no man's land, British infantry climbed out of their trenches and began walking toward German positions. They walked because each soldier carried 30 kilograms of equipment. They walked because their officers believed the artillery had destroyed German defences. They walked into the most concentrated machine gun fire in military history. Unteroffizier Karl Gottfried of the 99th Reserve Infantry Regiment described what he saw through his MG08 sights. They came on in lines like they were on parade. I could see their faces at 800 meters. Young men, most of them. They looked determined, brave. It didn't matter. I gave the command to fire. The gun hammered, the belt fed through, the spent cases clattered into the box. I traversed slowly, left to right, then back again. The first line fell. Just fell, all at once like they'd rehearsed it. But more came behind. Always more. We fired until the barrel glowed. My loader poured water over the jacket, the steam hissing. We changed the barrel, loaded a fresh belt, fired again. This continued for hours. The bodies piled up. They tried to use them for cover, but the bullets went through the bodies into the men behind. By noon, the ground in front of our position was carpeted with dead and wounded. The machine gun was hot enough to boil water in the jacket. We'd fired over 20,000 rounds. The barrel was shot out, the rifling gone. We installed our spare barrel and waited. They didn't come again. On July the 1st, 1916, the British Army suffered 57th Handjuse and 470 casualties, 19,240 of them killed. The majority fell to machine gun fire. German casualties for the same day totaled approximately 8,000. The disparity wasn't due to German superiority or British incompetence. It was the MG08, positioned in depth, with interlocking fields of fire, operated by trained crews. The mathematics of industrial warfare had spoken. The French Army's experience was similar. The Nivelle offensive of April 1917, intended to break through German lines in Champagne, collapsed against machine gun fire. Poilu Jean-Baptiste Dorget of the 153rd Infantry Regiment survived the attack on the Chemin des Dames. We were told the artillery had destroyed the German positions. We were told we would walk through to victory. We were told lies. The moment we left our trenches, the machine guns opened fire. Not one gun, dozens of them, hundreds. The noise was indescribable. The air itself seemed solid with bullets. Men fell in heaps. We tried to advance, we tried to dig in, nothing worked. The machine guns fired from positions we couldn't see, couldn't reach. Our artillery couldn't silence them. Our rifle fire was useless against concrete and steel. We lay in shell holes while bullets searched for us. 70% of my company became casualties in the first 20 minutes. We never advanced 100 meters. The French army suffered 187,000 casualties in 10 days during the Nivelle offensive. Machine gun fire accounted for an estimated 60% of casualties. The aftermath saw mutinies across 54 French divisions. Men weren't refusing to fight. They were refusing to walk into machine gun fire without realistic objectives or adequate support. The German defenders, equipped with their MG08s in prepared positions, lost approximately 163,000 men during the same period, a casualty ratio that demonstrated defensive advantage but still represented staggering losses. By 1917, both sides understood that machine guns made frontal assaults suicidal without combined arms support. But understanding a problem and solving it were different things. Artillery could suppress machine guns temporarily, but crews sheltered in deep dugouts and emerged when bombardments lifted. Tanks could survive machine gun fire, but were too slow, too unreliable, and too few to exploit breakthroughs. Infantry tactics evolved toward infiltration and small unit actions, but these required extensive training and didn't address the core problem. Machine guns controlled space. The MG08's practical range of 2,000 meters meant that any point within that radius was under potential fire. The weapon didn't need line of sight. Indirect fire techniques allowed machine guns to engage map coordinates, dropping plunging fire into approach routes, communication trenches, and assembly areas. German machine gunners trained to memorize range cards, detailed diagrams showing distances and azimuths to key terrain. At night, or in fog, they fired on coordinate data alone. British troops discovered this the hard way during the Third Battle of Ypres, Passchendaele, in late 1917. Even when German positions weren't visible through rain and mud, machine gun fire found them. The maintenance requirements for MG08s in trench warfare were substantial but manageable. Each gun required daily cleaning, weekly detailed strip and inspection, and monthly armourer service. The water cooling system needed flushing to prevent mineral deposits. The bolt mechanism required lubrication with a specific grease formulation that worked in temperatures from -20 to +40 Celsius. Barrels wore out every 10,000 to 15,000 rounds and required replacement. During major offensives, guns might fire that many rounds in a single day. The German logistics system kept spare barrels, bolts, springs, and other wear parts flowing to frontline units. More challenging was ammunition supply. An MG08 could exhaust its basic load of 4,000 rounds in 10 minutes of sustained fire. During defensive battles, ammunition consumption was staggering. The Defense of Verdun in 1916 saw German machine gun units firing an estimated 20 million rounds per month at the battle's peak. This ammunition came in 100-round canvas belts packed in wooden crates. Each crate weighed 26 kilograms. To supply a single machine gun position with enough ammunition for one day's defensive battle required transporting 50 to 60 crates, over 1,500 kilograms of material, forward through trenches under artillery fire. German supply troops, the Trager, performed this work nightly, hauling ammunition, water, food, and other supplies through communication trenches that might stretch 2,000 metres from rear areas to frontline positions. During major battles, this human logistics chain strained to breaking point. The MG08's water cooling, while allowing sustained fire, presented its own challenges. Each gun required 5 to 6 litres of water per hour during sustained fire, accounting for evaporation and steam loss. In summer, this wasn't difficult. In winter, water froze. German crews learned to add alcohol or glycerin to water jackets as antifreeze, though this reduced cooling efficiency. The most serious problem occurred when water supplies ran out during combat. Without cooling, the MG08's barrel would overheat after 250 rounds, potentially causing cook-offs where chambered rounds fired spontaneously from residual heat. Desperate crews urinated into water jackets or used any liquid available, including wine found in French cellars. The alternative was a weapon that couldn't fire, which in defensive combat meant death. Despite these limitations, the MG08 proved remarkably reliable. Captured German war diaries mention weapons firing 50,000 rounds or more with only basic maintenance. British and French intelligence officers examining captured MG08s consistently noted their robust construction and quality materials. One report from 1916 noted, "The German machine gun is manufactured to a standard that exceeds British peacetime commercial goods. Every part is fitted with precision. The weapon is designed not for minimum cost, but for maximum reliability." This represents a fundamentally different manufacturing philosophy. That philosophy reflected German industrial capacity and military priorities. By 1916, German factories were producing approximately 2,500 MG08s per month, plus the new lighter MG08-15 variant. This production continued despite British naval blockade, shortages of raw materials and labour conscription. The MG08 was essential. Everything else was secondary. The weapon's psychological impact matched its physical effectiveness. Soldiers on all sides developed profound fear of machine gun fire. The sound alone, that distinctive hammering roar, induced panic. Veterans could distinguish machine gun types by sound. The German MG08 had a slower rate of fire than British Vickers or French Hotchkiss guns, giving it a heavier, more methodical sound. British troops called it the sewing machine. French soldiers called it the moulin à café, the coffee grinder. The names were attempts to make something terrifying more mundane. It didn't work. The lethality was too obvious. Private William Grantham of the Lincolnshire Regiment wrote home in October 1916, describing an attack near Thiepval. "The worst part isn't being hit. It's hearing the bullets. They crack as they pass, a sharp snapping sound if close. When many pass at once, it sounds like someone snapping dozens of whips. You know each crack is a bullet that might have hit you, that might hit your mate." When a machine gun really opens up, the cracks merge into a continuous tearing sound, and you know that in that beaten zone nothing survives. Men I've seen try to cross through machine gun fire. Good men, brave men, they make it maybe 20 yards before the bullets find them. There's no skill that saves you, no courage that helps. Just mathematics and luck, and the mathematics favour the machine guns. The German army understood this psychological dimension and exploited it. Machine guns were positioned not just for maximum killing efficiency, but for maximum psychological effect. Guns placed to create crossfire, where beaten zones intersected, generated casualties and terror. Troops caught in crossfire faced bullets from multiple directions simultaneously, with no safe position. Survivors of such engagements frequently suffered psychological breakdown. The medical term was shell shock, but machine gun fire caused it as reliably as artillery. German defensive tactics evolved throughout the war to maximize machine gun effectiveness. By 1917, German doctrine called for defense in depth across 3 zones. The outpost zone, lightly held, absorbed enemy artillery and initial assault. The battle zone, 2 to 3 kilometers deep, contained the main defensive positions with machine guns in hardened emplacements. The rear zone held reserves for counterattack. This system, called elastic defense, allowed German forces to trade space for casualties. Attackers who penetrated the outpost zone found themselves in the battle zone, exposed to concentrated machine gun fire from positions that hadn't been artillery targets. The British offensive at Arras in April 1917 demonstrated this defence perfectly. British troops advanced successfully through the outpost zone, then struck the battle zone and its machine gun strongpoints. Progress stopped, casualties mounted. the offensive ground to halt against positions that artillery hadn't touched. German machine gunners in the battle zone had waited patiently in their dugouts, while British artillery pulverized empty trenches, then emerged and resumed their work of systematic slaughter. The counterattack role became increasingly important for MG08 units. When enemy troops penetrated German lines, machine guns positioned in the rear zone could engage them, from flanks or rear, catching them in the open. The gun's long range meant it could support counterattacks from positions 1,000 metres behind the front line. This created situations where Allied troops, having fought through the outpost and battle zones at terrible cost, found themselves under fire from guns they couldn't locate or engage. Lieutenant Hans Keller of the 17th Bavarian Infantry Regiment described directing machine gun fire during a British penetration in March 1918. We had 2 guns positioned on high ground, perhaps 800 metres behind the threatened sector. When British troops broke through into our second line, they were fully exposed to us. I calculated the range and deflection, set the guns accordingly. We fired on map coordinates, indirect fire, dropping a cone of bullets into the area where our infantry reported enemy presence. We couldn't see the targets, didn't need to. The British advance stopped. Their troops couldn't locate our fire, couldn't suppress us. After 15 minutes, 3,000 rounds expended, our counterattack retook the position. The prisoners told us their casualties were catastrophic. Men hit by bullets from nowhere, officers unable to identify fire positions, total confusion. This is the MG08's true power. Not just killing, but control. Dominance. The enemy moves only where we permit it. The weapon's versatility extended to anti-aircraft use. The MG08's effective range exceeded 2,000 metres horizontally and approached 1,500 metres vertically. Aircraft of 1914-1918 flew at altitudes the MG08 could reach. Specialised anti-aircraft mounts allowed machine guns to engage aircraft, though hitting them required considerable skill. Nevertheless, German records credit MG08s with over 200 aircraft shot down during the war, mostly low-flying reconnaissance or ground attack machines. The anti-aircraft role increased German flexibility. Machine gun positions that primarily engage ground targets could shift to air defence when aircraft appeared. This forced Allied aircraft to fly higher or face ground fire, reducing their reconnaissance and ground attack effectiveness. It also required more machine guns since each had to cover both ground and air threats. By 1918, a typical German division sector might contain 200 to 300 machine guns, up from 24 in 1914. This proliferation reflected both industrial capacity and tactical necessity. The MG08 was no longer one weapon among many. It was the primary weapon. Infantry rifles mattered, artillery mattered, but machine guns decided battles. German training reflected this priority. Machine gun crews received specialised training lasting 8 weeks, twice the basic infantry course. Gunners learned weapon maintenance, firing techniques, range estimation, and tactics. Loaders learned ammunition management, belt handling, and emergency barrel changes. Gun commanders, typically NCOs, studied terrain analysis, field fortification, and fire control. The best crews achieved remarkable proficiency. One celebrated team, Unteroffizier August Huber and Gefreiter Wilhelm Fischer of the 2nd Guard Reserve Division, claimed to have fired over 400,000 rounds in combat between August 1914 and November 1918. Their weapon, gun number 8544, supposedly never suffered a malfunction. This claim is likely exaggerated. The weapon would have required multiple barrel changes and part replacements, but it reflects the achievable reliability. The MG08-15, introduced in 1915 and refined in 1917, represented an attempt to create a lighter, more portable machine gun. At 18 kilograms with bipod, it could be carried by one man, unlike the MG08's team requirement. The 08-15 used the same action and ammunition as the MG08 but featured an air-cooled barrel, bipod mount and shoulder stock. It equipped squad-level infantry units, providing fire support for assault and movement. The 08-15 was less capable than the MG08. Its air-cooled barrel prevented sustained fire, limiting engagement to 250-round bursts before cooling pauses. Its lighter weight made it less stable and accurate, but it was mobile, allowing infantry to bring machine gun fire forward during attacks. By 1918, German doctrine called for 3 Oso 8-15s per infantry company, supplementing the heavier MG08s. This combination gave German infantry offensive and defensive machine gun capability. Despite the 08-15's advantages in mobile warfare, the MG08 remained supreme in defensive operations. Its sustained fire capability and longer range made it the preferred weapon for prepared positions. When German forces constructed the Hindenburg Line, a defensive system of immense complexity and strength, MG08 positions were central to its design. Concrete emplacements housed machine guns at intervals of 100 to 200 meters, each position supporting its neighbors with interlocking fire. The result was a defensive line that British and French forces attacked repeatedly throughout 1917 and early 1918 without breaking. The MG08 had become architecture. German offensive operations in spring 1918, the Kaiserschlacht, or Kaiser's Battle, demonstrated machine guns supporting attack. German stormtrooper tactics relied on artillery, infiltration, and squad automatic weapons. The MG08-15 provided direct support, but heavier MG08s were brought forward rapidly to consolidate captured positions. The German advances, which pushed Allied lines back 60 kilometers in some sectors, succeeded through combined arms operations where machine guns played a crucial role. But even in attack, German forces discovered machine gun limits. The MG08's weight-limited tactical mobility. Moving the weapon and its ammunition forward during exploitation required dedicated crews, slowing advance rates. When German offensives outran their supply lines and encountered fresh Allied divisions with their own machine guns, attacks stalled. The weapon that made German defense impregnable made German offense exhausting. The Allied counter-offensives beginning August 1918 exploited this weakness. British, French, and American forces, supported by tanks, aircraft, and overwhelming artillery, attacked on broad fronts. German machine gun positions, even when skillfully employed, couldn't stop attacks that came from multiple directions simultaneously. The MG08 was supreme in prepared defences, but prepared defences required time and resources Germany no longer possessed. The American Expeditionary Force's experience with German machine guns mirrored British and French learning at terrible cost. American troops, arriving in France in 1917 and 1918, brought enthusiasm and courage but limited tactical experience. German machine gunners viewed them as fresh targets. The Battle of Belleau Wood in June 1918 saw US Marines attacking German positions held by units equipped with both MG08 and MG08-15. Marine casualties were severe. First Sergeant Daniel Daly, a two-time Medal of Honor recipient, famously yelled, "Come on, you sons of bitches, do you want to live forever?" while leading a charge against German machine gun positions. His platoon suffered 50% casualties crossing 200 meters of wheat field under fire. The Americans learned quickly. By September 1918, during the Meuse-Argonne offensive, US forces employed artillery, tanks, and infiltration tactics against German machine gun positions. Casualties remained heavy, but Americans demonstrated they had absorbed the lessons British and French forces had learned at such cost. The machine gun was the problem, but combined arms were the solution. German production of MG08 and MG08-15 weapons totaled approximately 100,000 by November 1918. This represented extraordinary industrial effort under blockade conditions. The weapons required high-quality steel, precision machining, and skilled assembly. That Germany maintained this production, while facing shortages of virtually everything else, demonstrated the weapon's priority. Each MG08 required 400 hours of skilled labour to manufacture. At peak production, German factories completed 70 to 80 guns daily. The facilities at Spandau DWM in Berlin and several smaller contractors employed over 15,000 workers. Many were women, replacing conscripted men. Quality control remained rigorous throughout the war. Captured German machine guns examined by Allied technical intelligence consistently showed high manufacturing standards. The final months of war saw machine guns in every role: anti-aircraft, anti-tank, offensive support, defensive strongpoints, covering retreats. The MG08 had become the universal weapon. German forces withdrawing toward their borders in October and November 1918 used machine gun rearguards to delay pursuit, sacrificing crews to buy time for main forces to escape. These delaying actions worked. Allied forces advancing through Belgium and northern France encountered machine gun positions at every village, every bridge, every crossroads. German gunners, knowing the war was lost, fought to allow their comrades to survive. The cost was measured in crew after crew obliterated by artillery or overrun by infantry they'd fought to the last round. When the armistice took effect at 11 a.m. on November 11, 1918, the guns fell silent. In 4 years and 3 months, the MG08 had fired an estimated 100 billion rounds in combat. The weapon had killed or wounded millions. It had transformed warfare from maneuver and shock to attrition and industrial-scale slaughter. It had made traditional infantry tactics obsolete and forced every army to develop new methods or die trying. Post-war analysis by military historians attempted to quantify the MG08's impact. Casualty studies suggested that machine gun fire caused 30% to 40% of all combat casualties on the Western Front, with artillery causing most of the rest. In defensive battles, machine guns caused up to 60% of attacking casualties. The weapon's psychological impact exceeded its physical effect. Soldiers feared machine guns more than artillery because machine guns were personal. A shell fell randomly. A machine gun aimed at you. German veterans spoke of the MG08 with something approaching reverence. It had allowed outnumbered forces to hold superior numbers. It had protected German soil when nothing else could. Hauptmann Rudolf Binding, a German cavalry officer who observed machine gun actions throughout the war, wrote in his memoirs, "The machine gun made heroes unnecessary. Courage meant nothing against it. Tactical skill helped little. The gun fired, men died, the mathematics were simple." But it also made cowards unnecessary. A man behind a machine gun wasn't brave or cowardly. He was a technician performing a function. Pull trigger, traverse, fire again. The weapon reduced warfare to industrial process. This was efficient. It was also monstrous. The Treaty of Versailles, imposed on Germany in 1919, restricted German military machine gun holdings to a few thousand weapons for a 100,000-man army. The remaining MG08s were destroyed or distributed as reparations. Yet the weapon's influence persisted. Every nation's interwar machine gun development reflected lessons from the MG08. Sustained fire capability, water or air cooling, belt feed, tripod mounting, these became universal features. The Soviet Union's PM1910, a licensed copy of the original Maxim, used the same principles as the MG08. Britain's Vickers gun was nearly identical mechanically. American Browning designs incorporated different actions but similar doctrine. The MG08 had established the template. When Germany rearmed in the 1930s, the new MG34 and MG42 represented evolution, not revolution. They were lighter, had higher rates of fire, and used modern materials, but their tactical employment descended directly from MG08 doctrine. Sustained fire, interlocking fields, defensive strongpoints, the lessons of 1914-1918 remained valid. The Second World War would demonstrate this. German machine gun tactics in defensive operations from 1943 to 1945 succeeded through principles established with the MG08. The weapons changed, the mathematics didn't. The MG08 itself saw limited service in World War II. Some fortress and coastal defense units used old MG08s in fixed positions. China employed captured or purchased weapons through the 1940s. But the weapon's primary legacy was doctrinal. It had established that machine guns, properly employed, could control battlefield space, that sustained firepower trumped individual marksmanship, that defensive positions centered on machine guns were nearly impregnable without combined arm support. Modern infantry tactics still reflect these lessons. Fire and maneuver, suppression and movement, cover and concealment, all developed in response to the machine gun. The weapon that Wilhelm Schaefer aimed at French infantry in September 1914 established principles that remain valid in 21st century combat. At the Imperial War Museum in London, an MG08 sits in a recreated German bunker. The placard notes its technical specifications, its service history, the battles where this particular weapon fought. What it doesn't convey is the sound. That industrial hammering that men heard in their nightmares decades after the guns fell silent, or the smell, burnt powder and hot metal and the acrid tang of steam from the water jacket, or the sight of canvas belts feeding through the action, each round a potential death, 400 deaths per minute, sustainable for hours. A single MG08 crew, 2 men in a concrete pillbox, could inflict casualties that would have required a battalion of riflemen in previous wars. This wasn't military genius, it was industrial capacity applied to human destruction. The MG08 represented German engineering at its finest and most terrible. Precision manufacturing, reliable operation, sustainable production. The same qualities that made excellent machine tools made excellent killing machines. The German workers who assembled MG08s in Berlin factories couldn't know that their precision work was enabling slaughter on unprecedented scale. They were manufacturing to specifications, meeting quality standards, producing reliable products. That these products killed millions was someone else's concern. The generals who deployed machine guns understood their effectiveness, but not their implications. They believed machine guns would make defense temporarily stronger until new tactics emerged. They didn't foresee that machine guns would make offense nearly impossible, that the Western Front would become a static slaughterhouse, where gains were measured in meters and costs in hundreds of thousands of casualties. By the time they understood, it was too late. The guns were deployed, the tactics were established. The killing would continue until one side exhausted itself. That took 4 years. The soldiers who faced machine guns had the clearest understanding. They knew that crossing open ground under MG08 fire was suicide. They did it anyway, because orders demanded it, because their comrades depended on it, because the alternative was court-martial or execution. Hundreds of thousands of men walked toward machine guns they couldn't see, through fire they couldn't suppress, toward objectives they couldn't reach. Most died trying. Some survived and tried again. The ones who survived multiple attacks often broke psychologically. Shell shock, combat fatigue, what we now call PTSD. The human mind wasn't designed to face mechanical death repeatedly. It adapted or shattered. The MG08 created casualties that military medicine struggled to treat. Machine gun wounds were distinctive, high-velocity projectiles that tumbled through tissue, creating massive temporary cavities and extensive damage. Unlike rifle rounds fired at longer range, machine gun bullets typically struck with full velocity, transferring maximum energy. Surgeons in field hospitals recognized machine gun casualties immediately. The wounds were catastrophic, limbs shattered, organs destroyed, multiple hits common since machine gun fire swept areas rather than targeting individuals. A man caught in beaten zone might suffer 3 or 4 wounds from a single burst. Survival depended on which organs were hit and how quickly treatment reached the wounded. The statistics were grim. Machine gun casualties died at higher rates than artillery casualties. They required more extensive surgery, longer recovery, suffered more complications. The weapon that killed efficiently also maimed efficiently. The impact on German society was complex. Machine guns had defended German territory when invasion threatened. They had allowed smaller forces to hold superior numbers. In purely military terms, they were successful. But the casualties, German and Allied, created a generation traumatized by industrial warfare. The machine gun became symbol of everything wrong with the war: mechanical, impersonal, efficient killing. When German veterans spoke of the war, they spoke with horror of artillery barrages and resignation about machine guns. The guns were simply there, part of the landscape, as much a feature of the Western Front as barbed wire and mud. You didn't question them. You avoided them if possible, fought them if necessary, and died to them if luck ran out. The MG08's reliability meant German soldiers trusted it absolutely. When ammunition and water were available, the gun would fire. This trust extended to crews who maintained their weapons with obsessive care. Daily cleaning, weekly detailed maintenance, constant monitoring for wear or damage. Machine gunners knew their survival depended on their weapon's function. They treated their MG08s with respect bordering on affection. Guns received names, sometimes women's names, sometimes places from home. Crews personalized their weapons with small modifications, nothing that affected function, but markers of ownership and pride. This relationship between soldier and weapon was different from infantry and rifles. A rifle was personal equipment. A machine gun was a crew-served system. Its effectiveness came from teamwork. Gunner, loader, and commander functioned as integrated unit. The best crews moved with practiced efficiency, barrel changes completed in seconds, malfunctions cleared instantly, ammunition management seamless. These elite crews became force multipliers. One excellent machine gun team could achieve what 3 average teams might accomplish. The German army recognized this and formed machine gun companies. entire units equipped exclusively with MG08s and trained to employ them at company scale. These companies, deployed at critical points, could hold sectors that previously required battalions. The British and French developed similar organisations. Everyone understood. Machine guns weren't support weapons. They were primary weapons. Everything else supported them. The cult of the offensive, the belief that attacking infantry with rifles could overcome prepared defences, died in the wire before German machine gun positions. It died in the wheat fields of the Marne, the mud of Ypres, the chalk hills of the Somme. It died slowly, painfully, with casualties measured in hundreds of thousands. Because accepting that defence was stronger than offence meant accepting stalemate, and stalemate meant the war couldn't be won by traditional means. The machine gun, particularly the MG08, forced military thought into the modern era. It demonstrated that technology could shift tactical balance decisively, that industrial production capacity was military capacity, that warfare had become industrial process, victory going to whoever could produce more weapons, train more crews, supply more ammunition. Germany understood this. Their problem was that the Allies had greater industrial capacity. Britain, France, and eventually America could outproduce Germany. The blockade strangled German material imports. By 1918, Germany was producing excellent weapons from increasingly scarce materials. The MG08 required specific steel alloys. When those weren't available, quality declined. Not enough to cause failures in combat, German quality control remained excellent, but enough to reduce weapon life and increase maintenance requirements. The Allies faced different problems. They had materials but initially lacked designs. British Vickers and French Hotchkiss machine guns were effective but expensive and slow to produce. American entry into the war brought production capacity but not immediately weapons. US forces initially used French Chauchat light machine guns and British Vickers, both adequate but not preferred. American Browning designs, arguably superior to anything else fielded during the war, arrived too late to see significant service. If the war had continued into 1919, American production would have flooded Europe with modern weapons. The armistice made this unnecessary, but it demonstrated that the Allies had won the industrial race. They could replace losses faster than Germany. They could equip new divisions while Germany struggled to maintain existing ones. The machine gun, weapon of German defensive success, ultimately couldn't overcome material imbalance. November the 11th, 1918, 11 a.m. The gun stopped. Along the Western Front, machine guns that had fired almost continuously for 4 years fell silent. Crews secured their weapons, covered barrels, drained water jackets. Some men wept. Others sat numbly, unable to process that the killing had ended. The MG08 had done its work. It had defended Germany when invasion seemed certain. It had killed enemies by the millions. It had held positions that should have been indefensible. It had bought time when time was all Germany had. And it had failed. Because the machine gun, for all its effectiveness, couldn't win wars. It could only prevent losing. Offence required manoeuvre, combined arms, industrial capacity beyond what blockaded Germany could sustain. The MG08 had made German defence brilliant. It hadn't made German victory possible. The weapon remains a symbol of World War I's horror. When people imagine the Western Front, they imagine artillery, barbed wire and machine guns. The MG08 firing from concrete bunkers, sweeping no man's land with mechanical precision, killing efficiently and without mercy. This image is accurate. The machine gun dominated the Western Front more than any other weapon. It shaped tactics, strategy and outcome. A German weapon that killed more Germans through strategic stalemate and eventual defeat than it killed enemies. Schaefer, the lieutenant who watched French infantry advance in September 1914, survived the war. He wrote briefly about his experiences in the 1930s, about the first day he fired his MG08 in combat, about the men who fell, about nights wondering if what he'd done was necessary or simply murder by mechanical means. He concluded that the machine gun had destroyed something essential about warfare. It had removed honour, skill, courage from the equation. It had made killing industrial. A man with a rifle fought another man. A man with a machine gun processed targets. This troubled him, but he also acknowledged that the MG08 had saved his life, and those of his men countless times. In defence, when enemies attacked, the machine gun was salvation. It was only in reflection, after the war, that its true cost became clear. The MG08 had defended Germany brilliantly, and contributed to Germany's destruction. It had killed millions while failing to achieve victory. It had demonstrated that industrial warfare's mathematics favoured production capacity over tactical skill. These were hard lessons. They were necessary lessons. Modern military thought descends directly from them. The weapon that ruled no man's land for 4 years established principles that remain valid a century later. Concentrated firepower controls space. Defensive positions centered on automatic weapons require combined arms to overcome. Sustained fire. Capability matters more than accuracy. These truths were written in blood across the Western Front. The MG08 was the pen. At the end, the machine gun story is about inevitability. Once technology made such weapons possible, their employment was inevitable. Once employed, their dominance was inevitable. Once dominant, the slaughter was inevitable. Human courage, tactical skill, even numerical superiority couldn't overcome the mathematics of 400 bullets per minute. The only responses were industrial combined arms and material superiority. Germany had the weapon first and employed it best, but Germany lacked the industrial capacity to maintain superiority. The Allies learned, adapted, and overwhelmed through production. The MG08 had ruled no man's land. But no man's land wasn't enough to win the war. The weapon's technical supremacy deserves deeper examination. The MG08's action, while based on Hiram Maxim's original design, incorporated German refinements that made it superior to contemporaries. The toggle lock mechanism used a jointed arm that broke downward when the barrel recoiled. This design distributed stress across multiple bearing surfaces, reducing wear. British Vickers guns used similar principles but with lighter construction. French Hotchkiss guns used gas operation instead of recoil, making them simpler but less reliable under sustained fire. The MG08's toggle lock could cycle 400,000 times before replacement parts were needed. This represented roughly 100,000 rounds fired, assuming proper maintenance. In combat conditions, this translated to months or years of service life. Captured weapons examined by British Technical Intelligence in 1917 showed MG08s manufactured in 1914, still in frontline service with minimal parts replacement. One weapon, serial number 3847, captured near Cambrai, had fired an estimated 150,000 rounds based on barrel wear and unit records. It remained fully functional. The water cooling system's efficiency exceeded all contemporary designs. The 3.7-litre water jacket maintained barrel temperatures below 100 degrees Celsius during sustained fire. Steam generated during firing was captured in a condensation tube, a simple pipe exposed to air, where it cooled back to water and drained into the jacket. This closed-loop system minimised water consumption. In theory, an MG08 could fire indefinitely with only evaporation losses, perhaps 200 millilitres per hour. In practice, crews added water every few thousand rounds. The water itself became contaminated with powder residue that entered through the barrel during firing. After 5,000 to 6,000 rounds, this contaminated water reduced cooling efficiency and needed replacement. Crews learned to carry extra water specifically for the gun, separate from their drinking water. During summer battles, water consumption competed with soldiers' hydration needs. More than one German soldier died of dehydration because his crew's MG08 needed water more than he did. The ammunition itself represented engineering achievement equal to the weapon. The 7.92 Sek 57mm Mauser cartridge used smokeless powder, copper-jacketed bullets, and brass cases manufactured to tolerances of Zerub-Sommerheimkorn of 5mm. Each cartridge had to feed smoothly through the weapon's action, chamber reliably, fire consistently, and extract cleanly. Production quality that allowed this across millions of rounds was remarkable. German ammunition factories, primarily the Royal Arsenal at Spandau and DWM facilities, produced approximately 8 billion rounds annually by 1916. Each round required 15 separate manufacturing operations, from case drawing through final inspection. Quality control rejected roughly 2% of production for defects. This still meant 160 million defective rounds annually, but also 7.84 billion rounds that functioned flawlessly. The scale is difficult to comprehend. 8 billion rounds. If you fired 1 round per second, 24 hours daily, it would take 253 years to expend 1 year's production. The canvas belts that held ammunition were themselves critical components. Each belt held 100 rounds in fabric loops, with metal tabs connecting belts together. The fabric was weatherproofed canvas, resistant to water and dirt. The metal tabs were brass or steel, corrosion-resistant and precisely dimensioned. A poorly made belt could jam a weapon as surely as defective ammunition. German supply troops learned to inspect belts before forwarding them to combat units. They checked each loop for tears, verified metal tabs for damage, ensured even loading. Belts that passed inspection were packed in wooden crates, 1,000 rounds per crate, and shipped forward. Those that failed inspection were returned to depot for repair or destruction. Nothing was wasted. Even damaged belts had their metal tabs salvaged for reuse. The logistical burden of supplying machine gun units exceeded that of equivalent rifle companies by factors of 10. A rifle company of 250 men required perhaps 50,000 rounds of ammunition monthly for combat and training. A machine gun company with 12 MG08 kits might expend 200,000 rounds in a single defensive battle. Monthly consumption could reach 500,000 rounds or more during active periods. This ammunition had to reach frontline positions through supply chains that extended hundreds of kilometers from factories to trenches. Rail transported ammunition to forward depots. Horse-drawn wagons moved it to trench heads. Human porters carried it through communication trenches to gun positions. Each step was vulnerable to artillery fire, air attack, or simple logistical failure. German supply officers developed elaborate systems to ensure continuous ammunition flow. Buffer stocks at each level, forward depots holding 7 days' supply, trench dumps with 3 days' supply, gun positions with 24 hours' supply. When major battles were anticipated, these stocks doubled or tripled. The Battle of Verdun saw German machine gun positions holding 10,000 to 15,000 rounds per gun, enough for sustained defensive operations without resupply. The human cost of maintaining this supply chain rarely appears in histories. Thousands of supply troops died moving ammunition forward under fire. They didn't face enemy infantry. They faced artillery that targeted supply routes, air attacks against wagon convoys, and exhaustion from carrying 26-kilogram ammunition crates through muddy trenches night after night. Gefreiter Paul Steinberg served with Machine Gun Company's supply section from 1915 to 1917. His diary entries describe the work. Every night we carry ammunition forward. 40 crates, 1,000 kilograms total, moved through 1,500 meters of trench. The work takes 4 hours. We start at dark, finish near dawn. Artillery targets the communication trenches. We lose men weekly. The guns must have ammunition. If the guns fall silent, we all die. So we carry the crates. My back is permanently damaged. My hands are scarred from rope burns. I've carried more than 500,000 kilograms of ammunition in 2 years. I will carry more tomorrow. The gun crews themselves faced different stresses. Operating an MG08 under combat conditions required technical skill, physical endurance, and psychological resilience. The technical aspects alone were demanding. A gunner needed to judge range, calculate lead for moving targets, adjust for wind and elevation, control traverse and barrel elevation, and maintain awareness of ammunition consumption and barrel temperature, simultaneously. The loader had to feed belts smoothly, clear malfunctions instantly, monitor barrel temperature, prepare spare barrels for change, and track ammunition expenditure. Gun commanders coordinated everything, selected targets, adjusted fire, communicated with infantry commanders, and managed the crew's tactical employment. Elite crews developed into highly effective teams. Unteroffizier Franz Hessler's crew, serving with the 5th Bavarian Reserve Division, achieved minor fame within their regiment. Their MG08, nicknamed Emma after Hessler's wife, supposedly never jammed in combat across 3 years of service. This was likely exaggeration. All weapons malfunction eventually, but it reflected exceptional crew proficiency. Hessler's combat diary, captured when he was wounded in July 1918, described their methods. We clean Emma every evening, regardless of whether we've fired. We inspect every component weekly. We test fire monthly to verify function. We know her quirks, the slightly loose tripod mount that requires careful setup, the feed mechanism that prefers steady belt tension. We compensate automatically. During combat, I don't think about the weapon. I think about targets, ranges, fire control. The weapon functions because we've trained until operation is instinctive. This level of proficiency required time and training, Germany increasingly couldn't provide. Early war machine gun crews were professional soldiers or well-trained reservists. By 1917, replacement crews arrived with minimal training, sometimes just weeks on the weapon. The quality difference was immediately apparent. Experienced crews fired 50% more accurately, maintained higher rates of fire, and suffered fewer malfunctions than inexperienced crews. The Allies exploited this. British and French intelligence identified sectors held by veteran machine gun units and avoided them when possible. Attacks concentrated on sectors held by newer, less experienced crews. This forced Germany to distribute veteran machine gun teams across the front rather than concentrating them, diluting their effectiveness. The Americans, arriving fresh in 1917-1918, initially underestimated German machine guns, then overcorrected. Early American attacks showed reckless courage and heavy casualties. By mid-1918, American forces approached German positions with such caution that advances slowed unnecessarily. Finding the balance between aggression and prudence took time and cost lives. Captain Harry Truman, later US President, commanded an artillery battery supporting infantry attacks in the Meuse-Argonne. His letters home described frustration with machine gun positions. Our infantry attacks and German machine guns opened fire from positions we haven't identified. The attack stops. We call for artillery support, but by the time we locate the guns and fire, they've displaced or gone underground. We advance again. Different machine guns open fire. The cycle repeats. We're advancing, but slowly, and the casualties are terrible. Every 100 meters costs us men. The Germans don't have enough troops to stop us, but their machine guns make us pay for every inch. This was the MG08's final role. By late 1918, Germany's armies were exhausted, under strength, and facing overwhelming material disadvantage. They couldn't win. But machine guns allowed them to make Allied victory expensive, buying time for Germany to seek armistice rather than face complete collapse. The weapon's post-war fate reflected its effectiveness. The Versailles Treaty specifically limited German machine gun holdings because the Allies understood their impact. Germany was permitted 792 heavy machine guns for a 100,000-man army, roughly one gun per 126 men. This compared to wartime densities of one gun per 30-40 men. The limitation was designed to ensure Germany couldn't create the defensive strength that had characterized 1915-1918. Remaining MG08s were destroyed, shipped to Allied nations as reparations, or sold to various countries. Poland received several thousand as part of reparations. The Baltic states acquired MG08s for their new armies. China purchased or captured weapons that remained in service through World War II. Some MG08s saw combat in the Spanish Civil War, Korea, and even Vietnam, though by then they were obsolete curiosities. The Soviet Union's PM1910, essentially a licensed Maxim identical to the MG08's ancestor, served through World War II. Soviet machine gunners in 1941-1945 employed tactics developed by Germans in 1914-1918. Defensive positions, interlocking fire, sustained fire capability. The Soviets had learned from their enemies. The MG08's doctrinal legacy lived on. German rearmament in the 1930s initially considered modernizing surviving MG08s. Tests showed the weapons remained functional after 15 to 20 years in storage, but the new Wehrmacht wanted modern designs. The MG34, introduced in 1935, and MG42, introduced in 1942, represented the next generation. They were lighter, faster firing, and more versatile, but their tactical employment descended directly from MG08 doctrine. The MG42's 200 rounds per minute rate of fire created a sound Allied troops called Hitler's buzzsaw. It was terrifying and effective, but it was simply a faster MG08 in concept. Water cooling was replaced by quick-change barrels. The sledge mount became a lighter tripod. The action was simplified for mass production. The fundamentals remained unchanged: sustained fire, interlocking fields, defensive strongpoints. Modern military historians debate the MG08's strategic impact. Some argue it prolonged the war by making defensive operations too successful, leading to stalemate and attrition. Others counter that without machine guns, Germany would have been overrun in 1914, making the war shorter but equally costly. Both positions have merit. What's undeniable is that the MG08 changed warfare permanently. It demonstrated that defensive firepower could stop offensive maneuver, that technology could shift tactical balance decisively, and that industrial capacity determined military capacity. These lessons shaped interwar military thought and World War II operations. The blitzkrieg tactics Germany employed in 1939-1941 were responses to the MG08's legacy. Mobile warfare, combined arms, rapid exploitation, all designed to avoid static fronts where machine guns could create another Western front. When German advances stalled in Russia and Italy, defensive positions centered on machine guns. The tactics of 1918 remained valid in 1944. The personal stories of MG08 crews deserve remembering. These were ordinary men operating extraordinary weapons under impossible conditions. They weren't heroes or villains. They were soldiers doing jobs they'd been trained to do. That their job involved killing on industrial scale doesn't diminish their experience or their humanity. Unteroffizier Wilhelm Brenner served with machine gun companies from 1914 to 1918. He survived the war, returned to his family's farm in Bavaria, and lived until 1962. In the 1950s, his grandson interviewed him about the war. Brenner's responses, recorded on aging tape, provide insight into machine gunner psychology. "I was a good soldier. I followed orders, maintained my weapon, protected my comrades. I killed many men, hundreds, probably more. I don't know exactly how many." When you fire a machine gun at troops 800 meters away, you don't see individuals. You see masses, formations, target, areas. The gun fires, men fall, you traverse to new targets. It's mechanical. During combat, you don't think about the men dying. You think about technical things. Range, ammunition, barrel temperature, target priority. Afterward, you think about it. You can't help thinking about it. I dream about it still. Not nightmares exactly. Just dreams where I'm behind the gun again, firing, watching men fall. In the dreams, they're not French or British or American. They're just men. Young men like I was, like my grandson is now. They're dying and I'm killing them and I can't stop because stopping means my own death and my crew's death. So I don't stop. I fire until the attack ends or we run out of ammunition or orders come to displace. This was my war. 4 years behind a machine gun. I did my duty. I protected Germany. I survived. The men I killed didn't survive. I don't know if what I did was right or wrong. I know it was necessary. Or at least we believed it was necessary. Perhaps that's the same thing. Perhaps not. Brenner's ambivalence reflects broader German attitudes toward the war. Pride in having fought effectively mixed with horror at the war's cost. The machine guns symbolized both. German efficiency and German tragedy. A weapon that defended brilliantly but couldn't prevent defeat. The MG08's influence on popular culture has been minimal compared to other weapons. It appears in films and books about World War I, usually briefly during trench warfare scenes. It lacks the iconic status of later weapons like the MP40 or AK-47. This is curious given its historical impact. Perhaps the MG08's very effectiveness makes it uncomfortable. It's too closely associated with slaughter, too obviously a killing machine without romance or glory. When military museums display MG08s, visitor reactions are mixed. Some appreciate the engineering, others recoil from what the weapon represents. Few remain neutral. The weapon's purpose is too obvious, its effectiveness too well documented. This is a machine for killing humans efficiently. Everything about its design serves that purpose. The ammunition feed system, designed for continuous operation. The water cooling, allowing sustained fire. The sights, calibrated to 2,000 meters. The tripod mount providing stable firing platform. Every component reflects meticulous engineering applied to maximize lethality. This makes the MG08 honest in ways many weapons aren't. It doesn't pretend to be anything except what it is. Modern machine guns are descendants of the MG08, though technology has advanced significantly. Belt feed, quick-change barrels, optical sights, and synthetic materials improve on 1908 concepts. But the fundamental principle remains. Sustained automatic fire from a crew-served weapon positioned to control terrain. The MG08 established this model. Everything since has been refinement. The US military's M240 machine gun, standard today, fires 650-950 rounds per minute, nearly twice the MG08's rate. It weighs 12.5 kilograms, half the MG08's weight. It's more accurate, more reliable, and more versatile, but tactically it fills the same role the MG08 filled in 1914: defensive strongpoint, base of fire for manoeuvre elements, area denial weapon. The concepts haven't changed because the mathematics haven't changed. Sustained automatic fire controls space. The MG08's kill radius, the distance at which it could reliably engage targets, was approximately 1,000 metres in direct fire, 2,000 metres in indirect fire. Modern machine guns extend this to 0.800 metres and beyond. The principle scales, but remains constant. Control the space, control the battlefield. Training modern machine gunners involves teaching principles German instructors taught in 1908. Fields of fire, dead space, grazing fire, beaten zones. The terminology and concepts are identical. Military doctrine has absorbed the lessons the MG08 taught at such cost. Every army trains its machine gunners in the tactics German crews perfected between 1914 and 1918. The weapon's technical specifications, once military secrets, are now historical data. Caliber 7.19 to the .557 medal. Weight 26.5 kilograms gun, 32 kilograms mount. Length 1,175 millimeters. Barrel length 719 millimeters. Rate of fire 400 rounds per minute. Muzzle velocity 870 meters per second. Effective range 2,000 meters. Maximum range 300 to 600 meters. Feed system 250 round canvas belt. Cooling water jacket 3.7 litre capacity. These numbers defined battlefield reality for 4 years. The MG08 fired 400 rounds per minute, assumed 250 rounds sustainable rate accounting for cooling and belt changes. In 1 hour, 15,000 rounds. Each round could kill or wound. The theoretical lethality is staggering. One weapon, properly supplied, could engage targets continuously for hours, expending ammunition that represented thousands of potential casualties. This was never achieved in practice. Combat isn't theoretical. Targets take cover, return fire, call artillery. Gun crews suppress, displace, take casualties themselves. But the potential was there, and occasionally realised. There are documented instances of single MG08s firing 20,000, 30,000 rounds during day-long defensive battles, inflicting hundreds of casualties. The psychological impact on both operators and targets deserves emphasis. Operating a weapon that kills efficiently and continuously affects the operator. Some machine gunners became detached, viewing targets as objects rather than humans. Others suffered profound guilt that manifested after combat ended. Both responses were survival mechanisms. The human psyche isn't designed for industrial killing. Targets, men facing machine gun fire, experienced terror that exceeded normal combat fear. Artillery was random and impersonal. Rifle fire was individual. Machine gun fire was directed, sustained, and inescapable within the beaten zone. Men caught in machine gun fire described feeling hunted, targeted specifically even when the fire was area. Suppression. The psychological wounds lasted lifetimes. British veteran James Davidson, who survived multiple attacks against German machine gun positions between 1916 and 1918, suffered what would now be diagnosed as severe PTSD. His medical records from the 1920s describe panic attacks triggered by mechanical sounds, insomnia, violent outbursts. He was treated at several hospitals without success. In 1931, he committed suicide. His note mentioned, "The guns, always the guns, I still hear them." Multiply Davidson by thousands, tens of thousands. The MG08's psychological casualties matched its physical casualties. Men who survived machine gun fire physically often didn't survive it psychologically. The weapon destroyed minds along with bodies. German machine gunners suffered too. Operating a weapon that kills hundreds creates moral injury regardless of military necessity. Many German veterans refused to discuss their machine gun service after the war. When pressed, they described it as necessary evil, terrible duty, work that needed doing. The language reflects their discomfort. Some veterans, a minority, spoke openly about enjoying the power, the ability to stop attacks, to control battlefields, to make enemies fear you. This honesty is disturbing but valuable. War brings out extremes in human nature. Some men discover they're capable of things they never imagined. Machine gunnery provided opportunity for both heroism and monstrosity, sometimes in the same person. The weapon itself was morally neutral. It had no agency, no intention. But its effects weren't neutral. The MG08 killed more efficiently than any previous small arm. It made warfare more terrible. It contributed to casualty scales that broke nations and traumatized generations. These weren't unintended consequences. They were the weapon's purpose. The MG08 was designed to kill efficiently. It succeeded. Modern ethicists debate whether weapons can be immoral or only their use can be immoral. The MG08 tests this distinction. If a weapon's only purpose is killing, and it achieves that purpose with unprecedented efficiency, does the weapon bear moral weight? Or does all moral responsibility rest with those who built, deployed, and fired it? There's no satisfying answer. But examining the question through the MG08's history illuminates the problem. The weapon enabled slaughter on industrial scale. It made possible casualty rates that shocked even contemporary observers hardened to war's horrors. Without the MG08 and weapons like it, World War I would have been terrible. With them, it became catastrophic. The final accounting of the MG08's impact exceeds simple statistics. Yes, it killed millions. Yes, it defined the Western Front. Yes, it changed warfare permanently. But it also represented something larger. The application of industrial precision to human destruction. The transformation of killing from individual act to mechanical process. The subordination of human courage, skill, and will to technological systems. These transformations didn't begin with the MG08. Artillery and naval guns had already industrialized warfare, but the machine gun brought industrial warfare to individual combat. A rifleman still aimed at individuals. A machine gunner processed target areas. The distinction mattered psychologically and philosophically. The MG08 demonstrated that human qualities, courage, determination, fighting spirit, the things armies had valued for millennia, mattered less than firepower and industrial capacity. A brave man charging a machine gun died the same as a coward. Skill mattered little when bullets saturated the battlefield. Victory came not from superior warriors, but from superior production. This was World War I's central lesson. Industrial capacity determined outcomes. Germany lost not because German soldiers were inferior, they often fought brilliantly, but because Germany couldn't match Allied production. The MG08 was excellent. But excellence meant nothing when enemies could field adequate weapons in greater numbers. By November 1918, Germany had produced approximately 100,000 MG08, and MG08 just 15 weapons. The Allies had produced roughly 250,000 machine guns of various types. Germany's weapons were often better individually. British Vickers guns were heavier and more complex. French Hotchkiss guns were less reliable. American Brownings arrived too late. But Allied numerical superiority overwhelmed German technical superiority. This pattern would repeat in World War II. German weapons, Tigers, Panthers, MG42s, were often superior individually. But Allied production, T-34s, Shermans, thousands of machine guns, overwhelmed through numbers. The MG08 had established the paradigm. Quality matters. Quantity matters more. The weapon that ruled no man's land for 4 years taught lessons military establishments have absorbed but civilians often miss. Technology shifts tactical balance. Industrial capacity determines strategic outcomes. Human courage and skill matter but can't overcome material disadvantage. These truths are uncomfortable. They suggest that wars are won in factories more than battlefields. The MG08's history confirms this suggestion. When the last MG08 fired its last round in combat, probably in some forgotten skirmish in China or Southeast Asia decades after World War I ended, it closed a chapter in military history. The age of the heavy, water-cooled position machine gun was ending. Lighter, air-cooled weapons were taking over. But the MG08's doctrinal legacy remained still. The principles German machine gunners developed between 1914 and 1918 are taught to machine gunners today. The MG08 ruled no man's land through mechanical efficiency, industrial precision, and tactical employment that maximized its strengths. It killed millions not through evil intent but through effective design applied at scale. It changed warfare by demonstrating that defensive firepower could stop offensive maneuver, that technology could dominate tactics, that industrial capacity was military power. The weapon sits in museums now, silent, oiled, harmless. Plaques explain its history. Visitors photograph it, read specifications, move on. Few comprehend what it represented. the industrialization of killing, the mechanization of warfare, the moment when human combat became inhuman process. The MG08 was that moment made physical, a machine for killing humans, designed by humans, built by humans, operated by humans, killing humans, all very efficiently, all very terrible, all very modern. The gun that ruled no man's land ruled because it embodied everything the modern age brought to warfare: precision, power, efficiency, scale, applied to destruction.